In some languages, object-oriented programming is the main style of programming, and functional programming is more of an afterthought. Java, C#, and C++ are examples of languages like that. In other languages, functional programming is the main approach, and object-oriented programming is more of an afterthought. Lisp, Scheme, Ruby, and JavaScript are examples of languages like that. So the functional programming approach we discussed in the previous section is very strong in JavaScript. The object-oriented programming approach that we'll discuss in this section is quite a bit weaker, and it's more of a cursory, basic functionality, but not a full-blown, rich object-oriented programming capability like languages like Java and C# have. Nevertheless, you can make objects, and they're relatively simple. So the idea is you make a function, and the function has the name of a class. And although this looks like you're making a class, the difference is that JavaScript is a dynamically typed language. So although you can define a person class and a circle class and make instances, objects that belong to that class, it's not a new type. So there's no type called person, no type called circle, and so forth. And so if you're new to programming altogether, this doesn't seem so strange to you. You're used to dynamic typing. But if you come from an object-oriented language, you think of a class as a type, and JavaScript doesn't have that. Inside of this function, you'll use a special funny variable called this. When you assign to this dot something or another, like this dot first name for a person class, then that becomes a field or a data member or an instance variable of that class. And then you use the new constructor to make instances of this class. All right, that's a high-level summary. Let's take a look at some real code. So I make a function called person. It's a little bit odd that it's a function because you're going to use it not in the normal way that you use functions to call it and get a return value, but instead to build instances of an object. By convention, when you make a function that's going to act as a constructor for building a class, you start it with an uppercase letter. Most normal JavaScript functions start with a lowercase letter. It's just a convention. The JavaScript compiler doesn't enforce this, but it's a very good convention, and I strongly recommend that you follow it so that people who come along and maintain your code later understand which of the functions are sort of normal functions and which of the functions act as constructors for building instances of classes. All right, in this case, my function, my constructor function, takes two arguments. I can name them whatever I want, but in this case I call them first name and last name. And then the most important point is that I use this special variable called this. When you use this, it assigns to a field of the object that the constructor builds. Now, there's no law that says the variable that you pass in has to match the name of the field, but it's conventional to do it that way. So this says, take the variable that you pass in, first name, and assign it to the first name field or data member or instance variable or property. And then the next line says, take the second argument that you pass into the constructor and assign it to the field, the property, the data member, last name. All right, so now I want to build an instance of a person. So I say new. I use my constructor function, and I supply some arguments. So if you look at the code above, Polly will get assigned to the first name field, and programmer will be assigned to the last name field. And so you access those fields with a dot. So once I've made a person P, if I look up the first name, I'll get back what I passed in for the first name. And if I look up the last name, I'll get back what I passed in for the last name. So this is not complicated. It's quite simple and straightforward. It's just not very rich. There's not a wide range of object-oriented programming constructs like there are in many other languages, but it's straightforward and simple, and objects are a good way of organizing your code. So rather than having a separate variable for Polly's first name and Polly's last name, and then for Joe's first name and Joe's last name, and for Jane's first name and Jane's last name, and all these variables lying around, you group them together in an object. All right, so that's the basic idea. Build a constructor, give it an uppercase letter, use the this variable, and then build instances with new. But if you've seen object-oriented programming before, you know that constructors and fields are not the only thing that you care about. You may also care about methods, and we'll discuss that in the next section. Okay, let's talk a little bit more about properties and some of the features of properties in objects in JavaScript, and then briefly introduce methods, then go back and look at them in a little more detail. All right, so here is the person class that we showed in the previous slide. And if I run that, it defines a constructor function, and I can say var p equals new person, first name Polly, last name programmer. I run that, and then I say p dot first name, and I get Polly, and p dot last name, and I get programmer. So if you've seen objects in other languages, so far this seems pretty standard and straightforward. It doesn't seem so weird. And in truth, it's quite simple and easy to understand, which is an advantage over some of the very large object-oriented programming languages. But there's a few odd features. One of the features is that you don't have to define all of the fields in the constructor. You can add new fields later anytime by just assigning to them. So it makes perfectly good sense that you might want to change a field. So I can say p.lastname equals, and she's not she got married and decided to change her last name, and so now it's Polly the developer instead of programmer. And now if I look up the last name, it's developer. Okay, makes sense so far. But here's the really strange feature. What if I say p dot middle name? Well, when I defined the person constructor, there was no middle name field. But I can assign to it anyway. Q, Polly Q developer. And now if I look up p dot middle name, sure enough, there is a middle name field. Now, some people think that this is very convenient. Oh, I can kind of divide my definitions into pieces, put some of the pieces in the constructor, and then later on go and add some other pieces later if I decide that I need extra capabilities in my class. But other people think, no, this is a bug. And the reason some people think this is a bug is if you make a typo. So let's say that I decide that I'm going to change her first name, and instead of it being Polly, it's Pollyanna. All right, do you see what I did wrong here? The real name of the field was first name capital N. But I made a typo in my code and I called it first name lowercase n. And the problem is JavaScript said, fine, I'll just make a new field called first name lowercase n and assign to it, and I won't give you any warning. And so this is an example of a general principle. Compared to other programming languages, JavaScript catches fewer errors at compile time, or the time that you write and deploy your code, and has more errors at runtime. A lot of programmers think that that's bad. And so I would argue that this is not a good feature of JavaScript, because if you make a typo in your code, and I don't know about you, but I make lots of typos in my code, and you name the field wrong, in this case with a lowercase n instead of an uppercase n, JavaScript doesn't warn you. So, two principles. One, define all of your fields in the constructor function. Don't try to go and add fields again later. And secondly, be very careful in your testing, because if you update a field and you spell the field wrong, you will never be warned. It'll just add a second field. So, for example, I have a first name field, Pollyanna, and a first name field poly. Probably not a good thing. And then another odd feature of fields or properties is that methods, functions that belong to objects, in some sense are really just properties whose values happen to be functions. Now, there's a little twist on that we'll get to it in a little bit, but the general point is that all JavaScript objects have are properties, fields, data members. And they can be strings, they can be numbers, or they can be functions. So I could make a full name property. But the full name is not fixed, because if the first name or the last name changes, the full name would also change. And it may be that in different countries you format the full name differently. Sometimes you put the family name first and then the given name. Other places you give the given name first and then the family name. So it should be a function that is determined by the other fields. So I'll say it's a function. And in the function, let me put this on the next line to make it a little more clear. I will return this dot first name plus a space plus this dot last name. Make sure you spell the fields properly. So I'm just assigning to a field but giving it a value that's a function. And so now if I look up p dot full name parentheses, it's a function call, I get Poly Developer. It's important that I made it a function because if I change her name, last name back, p dot last name equals programmer, I want the full name to automatically pick it up. So the full name needs to be a method, a function whose value is determined by the other fields. Okay, so this isn't bad in all ways. It's consistent with JavaScript's theme that functions are first-class data structures, but it is a little bit unusual that you can add fields to classes retroactively later, and this has some bad results if you make typos. And it's a little bit unusual that there's not a fundamental distinction between regular fields and methods, fields whose values are functions. So let's go back and look at that in a little more detail in some slides. So let's define a reusable constructor function for building instances of circles. Maybe I'm doing some geometric calculations, or maybe I have circular areas on the floor that I need to paint. I need to calculate their areas. So I make a constructor function called a circle. Notice it begins with an uppercase C to indicate to the other developers this is not a normal function that you just call and get a value back, but it's a constructor function that returns an object that will have fields, data members, instance variables, properties that I will look up later. I will pass in a radius and store it in the radius field. And I'll make a property called getArea whose value is a function. And just like the full name function or method in the previous example was determined by the first name and last name fields, the getArea method is determined by the radius field. So it can't just be a number, because if you change the radius, the area has to change automatically. So I'm going to calculate the area based on the radius. And so my function is going to say, look up the radius and square it, multiply it times pi, and then return that result. So I can build an instance of a circle. Notice that I use the new operator. I pass in a radius of 10. I can look up the radius. Sure enough, it's 10. And I can look up, or more precisely calculate, the area. Notice the parentheses. GetArea is a method, a member function, and it gets pi r squared. If I change the radius and I look up the area again, the area will have changed. All right, so this is reasonable, and it's consistent with JavaScript's theme of first-class functions. Methods are just properties whose values are functions that use fields. However, there's a little bit of an inefficiency involved with this, and I want to discuss that in the next section where we look at the prototype property.